All right, let's talk about math education. The big question, has math education been failing thousands of students? And we look at the NAEP trends to answer that question. So NAEP is the National Assessment of Educational Progress. And as you can see, the lines for the groups that are tested, age 17, 13, or 9 on this particular test, all the trend lines tend to go up from 73 to 2012. So this is all pre-Common Core. In 2015, all of the grades went down for the grades that are tested, grade 4 and grade 8. So what this tells us is the Common Core influence of math caused the test scores to drop. You also see that when comparing the nation versus Texas. This is 8th grade NAEP scores, 1990 to 2015, and you can see the trend starts to go down in the 2015. And this is what Dr. Milgram was talking about during the November meeting, how steep the tangent is of that curve. That indicates there's a big problem in math. Here's the same test results by percentiles. So you can see it affected everybody. Even the 90th percentile students have the same dip in the scores. 4th grade, you don't see as big of a change. You see it nationally, but not in Texas. That's kind of curious. But as Dr. Milgram stated, 4th grade, it's kind of hard to tell. You really start seeing it in 5th grade. So that's the same NAEP scores by percentile. So they held fairly steady from 2013 to 2015. So these charts were created from the TA website. These are passing scores. This is Algebra 1 for spring of 2016. A 37% is considered passing. What do students really understand about Algebra 1 if a 37% is passing? Here are the trends of passing scores from 2011 through 2016. So first column is grade 3, 4, 5, 6, 7, and 8. So you can see it's increasing in years. So decreasing year. The first column is 2016. So you can see that the test scores for grades 3 through 6, well, actually 3 through 7, are lower than they've been in previous years. And here it is for Algebra 1 through Algebra 2, so geometry. Some of the data just wasn't available on the website. But you see that the average, 36, 37% is passing. I think this means that the students really don't have a good understanding of the fundamentals. So let's talk about Common Core math. If you have 4 pencils and 7 apples, how many pancakes will fit on the roof? Purple, because aliens don't wear hats. That sounds ridiculous, but when you start looking at how math is being taught, it's just as ridiculous. Here's how they're teaching multiplication facts. Instead of memorizing your multiplication tables, you have these strategies. To multiply by 6, you use the strategy multiply by 5 and add the number to the result. So you just here's the half tens fact. To multiply by 5, multiply the number by 10, then divide the result in half. So you've taken a simple memorization and made it a two-step problem. Same thing, modeling. You see a lot of this in the standards, requiring modeling. Here's modeling polynomials with algebra tiles. And below is how you do it, how we were all taught, using the FOIL method. First, outer, inner, last, multiplying each of the terms. These algebra tiles are not useful when the coefficients aren't even numbers. Or what do you do when you have a third order polynomial or a fourth order polynomial? What does the model look like when you get into those? And you have these kinds of questions, where you have pictorial models. Pictorial models are called up quite a bit in the third through, I guess third through eighth grade is where you see most of it. So we talked about how the standards preach a process over content. This was a question that a KDISD parent sent to me. And the student got it wrong. 5 times 3 is equal to 15. They got it wrong. Because how the teacher is teaching this, the order matters. This isn't 3 jumps of 5, it's 5 jumps of 3. So the model would have been right had there been 5 jumps of only 3 spaces. Then 5 times 3 would be right. But as we know, you can multiply 5 times 3 or 3 by 5 and get the same answer. And it's the answer that's the most important, not the process and how you got there. So here are some examples of wording in the TEKS that creates the needs for those types of problems. This is going to go over a 5th grade problem, and you can see here in the standards it says represent multiplication of decimals using objects or pictorial models, including the area model. So it's that wording in the content portion of the standard that creates the need for this type of problem. Anybody know how to use that model to solve this multiplication problem? It took me a while to figure it out. So you put the numbers on the sides, and wherever they overlap, when you shade it in, that's your answer. So you got 4 representing the 4 tenths on the top, and then 8 tenths on the side, and where they overlap, that's your solution. The kids don't have to do the math, they just have to recognize the model. Same thing here, problem 10. You're testing a process or a method of solving the problem. And there's the wording in the standards that creates the need for that. Represent integer operations with concrete models. So here's a number line again with jumps. They don't have to do any math, just recognize the model. Again, question 11. This is a 3rd grade. This example problem is actually a good one, but look at the wording of this standard. Using objects, pictorial models, including arrays, area models, equal groups, property of operation, and recall of facts. That's 7 different ways of multiplying. Now this problem was a good one, but it could have included any of those methods. Could have tested on any of those 7 methods. So now, instead of teaching the fundamentals of multiplication or memorizing your multiplication facts, the teachers have to spend time teaching all 7 of those methods. What gets left off in a school year when you have to spend this amount of time on that type of method? Again, models. This is 7th grade. So 7th grade, you're still dealing with models. And this doesn't really help you in upper level math. If you can only solve this problem by drawing rectangles and squares, do you really understand algebra? I like this one. This is a 5th grade problem. Describe the meaning of the parentheses. I would rather the student know how to use them in a math problem, not describe them. So these are the STAAR test, grades 3 through 8 in Algebra 1. The percent of the questions testing a process or a methodology instead of content. And in the 2015, they didn't release all the questions, but you can calculate a percentage of what they did release. And you can see 28% in 3rd grade are testing a process or a method instead of true mathematics. I actually thought the 2016 tests were a little better, especially in the upper grades. And in Algebra 1, you don't see these types of problems. Algebra 1, it seems like geometry, I haven't done Algebra 2 yet. Algebra 1 and geometry, the coursework seems to be okay. The standards are still pretty good for high school. So Dr. Mogram actually confirmed that in November as well. But you're still, 10 to 28% testing a process on these different grade levels. Oh, I went the wrong way. If you really want a good understanding of this math battle that's been going on, it's been going on quite a while. There's two documents that I recommend you read. One is David Klein's A Brief History of Mathematics Education in the 20th Century. The other one is H. Wu's Basic Skills versus Conceptual Understanding, A Bogus Dichotomy in Mathematics Education. They're both very good to understand what's going on in math. And all of my testimonies, all 15 of them, I think I might have put the 3 Senate Education Committee meetings that I testified on there as well. My YouTube channel, Republic of Texas Tackling Education Nonsense, or Rotten for short. Or you can always email me, that's my email address. And that's all I have for math.